Hi guys, it's Reza from Cat Space, and this week's video blog is about new features in SolidWorks Simulation 2017. So this is a Myo Pro grasping mechanism, as you can see here, and this simulation that I would like to show here is actually done on this controller. So I just opened this sub-assembly separately over here, and let's just take a look here. So this door is fully open. This is the door that actually holds the battery on this controller, and I would like to see what is actually going to happen if this door is fully released, and what is actually going to happen on these side tabs over here. So in order to do so, I'll just open this file separately, and usually when I want to do a simulation on a part or an assembly, I make a new configuration, call it FEA, in case I want to make a cut like this. So a study has been prepared by me from before. I have chosen to put a prescribed displacement on this edge, push this by 2.3 so that I can simulate on this, have a simulation done on this part. Let's run this analysis. New in 2017 is now the solver actually can make a decision automatically. So it actually not needed for you to be presented in front of your machine to say yes or no. It automatically makes a decision, and that's really good, because if you leave your computer for a coffee or a meeting for lunch, when you come back, if it was previous versions, you could still see that this the message is over there and nothing actually has been happening there. So you actually wasted an hour of time, but this way it actually does the analysis and makes a decision on your behalf. So the first thing you could see over here is for the stress values more than the high or maximum annotation of this legend, you get to choose the color now easily by clicking on this sort of top legend here. So you can change it anytime you want. So let's say 13 is the maximum stress that you actually chose for this figure, but this area shows that is actually much higher than 13. New tool in 2017 is this stress hotspot diagnostics. That's one of the greatest feature in 2017. It's capable of detecting the area which has got the possibility of having singularity in the model. So you would think that if I push this model in, or push this side tab in on this edge, you could think that why these stresses in here are so high. So there's like a tool, stress hotspot, that is capable of detecting these elements and telling you you have to be careful with these elements, because the adjacent elements to these ones have got a high difference in stress. That's a very good candidate for stress singularity. So you could just, if I want to show you here, this edge can actually turn to a fillet, and a fillet could exist here to get rid of this singularity. Let's go back to the controller assembly so that I can show you another highlight of SolidWorks simulation in 2017. So if you do a simulation on this body only in the assembly, you know that you could exclude these components, the rest of the components such as these ones, all of these, and just focus on that part. And at the end, you get the stress results and show the whole assembly and the results of this only as well. So this door's stress figure is there, while other components, but you could easily realize that, by the way you could do that is under settings of your stress plot and then show excluded bodies. But in 2017 it's actually has been improved a lot, because the graphics wasn't good that much. There's a new simulation display introduced in 2017. So activating that, it asks you whether you want to put a stress or deformation or displacement. You can have a deform results or showing the mesh as well. So if you're dealing with more technical or FEA people in your company, you can actually show the mesh as well. So it shows you in your real view graphics over here. And another important thing is you can do a rendering on this model and have this part or this simulated sort of component over there and put it on the render part, which looks really nice and helps you a lot when you want to communicate the results of your simulation to someone else.